So in last class we have seen stress and strain, and today we will see the use of significance of elastic constant, why the elastic constant come into the picture. So till now we have discussed that whenever there is a material under any kind of threat, it has two responses. One response is called stress, another response is called strain, right? And the stress is something that can be experienced by the material under the action of the load, and strain is a kind of response that can be visualized as well as we are able to determine that, or we are able to measure it, right? Also we have seen in the last classes what is stress, what is strain, right? And also seen strain cannot be calculated theoretically, right? It is calculated experimentally only, right? So if we are interested to calculate strain theoretically, we require the elastic constant. So in today's class we will discuss significance of elastic constant and why these are used, and which elastic constant are used to develop the relation between stress and strain, which stress and which strain. Okay, so for any homogeneous and isotropic material there are four elastic constant, and these are the four elastic constant, and the basic purpose of these elastic constant are these are used to develop the relation between stress and strain or to calculate strain theoretically. In previous lecture we have seen strain theoretically we are not able to calculate. If we are interested to calculate strain, we have to conduct a experiment. If we are interested without calculating or without any experiment to calculate the strains, different kind of strain we have seen in the last class, so we required the elastic constant, right? For any homogeneous and isotropic material there are four elastic constant. One is called modulus of elasticity. It is also known as, in many books it is also known as Young modulus. Young modulus, and generally it is represented by E. Generally it is represented by E. Another one is modulus of rigidity. In some book it is also represented by C. Bulk modulus, it is represented by K. Poisson ratio, it is represented by mu. And the meaning of homogeneous and isotropic is that any material is said to be homogeneous and isotropic if it exhibit all the material property same at each and every point and direction. Means whatever the material constant we are choosing with respect to point and with respect to direction, all must be same. If I am considering another point on the body and direction, the material constant is same, then the material is said to be isotropic and homogeneous, right? So one by one we will see how these elastic constants are very useful to develop the relation between stress and strain, which stress and which strain, right? So first we are interested to see modulus of elasticity. Modulus of elasticity is generally used to develop the relation between normal stress and normal strain, just like we can see here. So modulus of elasticity basically used to develop the relation between normal stress and normal strain. Which normal strain? Basically it is used to develop the longitudinal strain, right? Or we can say to calculate longitudinal strain theoretically. If we are interested to calculate longitudinal strain theoretically, so which constant we have to use? Modulus of elasticity, that is also known as the Young modulus, right? So we can easily understand that within elastic limit, whatever we are discussing in this class, that is within elastic limit. The meaning of elastic limit is that if any force is applied on the body, there is some change. After removal of the force, body will regain its original shape. Means there is no permanent change in the body. So whatever I am discussing in the class, all thing I am discussing within elastic limit. Means after removal of the force, body will regain its original shape. Means there is no permanent deformation. There is only change, that is the temporary change. As long as the force is acting, there is a change. If we remove the force, there is no change. Body will regain its original shape. So that's why I am saying within elastic limit, or sometimes it is also known as proportional limit. Also, sometimes it is proportional limit. We can say normal stress is directly proportional to the normal strain, and generally we are talking about the normal strain is longitudinal strain. So as we remove the proportionality sign, a constant come into the picture that is called E, modulus of elasticity or Young modulus, right? So here we are able to calculate longitudinal strain theoretically. Means how we are able to calculate longitudinal strain theoretically? By using this formula, right? Normal strain we can calculate theoretically. We know the external load acting over the body divided by the cross section area. E, the value of E for a particular material is a fixed value, right? That is also the experimental evidence. For the different materials, we have the different value of E. How these value come basically, that is also based on the experimental evidence. But we have value of E fixed for each material. So there is no problem for any kind of material, we have the value of E. So E is also known to us theoretically now, and we put this sigma n and E, we are able to calculate theoretically longitudinal strain. So that is the significance of elastic constant. With the help of this modulus of elasticity, we are able to calculate longitudinal strain theoretically, or we are able to develop the relation between normal stress and normal strain. Now, we have to understand the significance of this modulus of elasticity. So we are going deeper. If I am assuming that this strain is equal to 1, if the strain is unitary, if the longitudinal strain is unitary, what is the meaning of that? What is a strain basically? If we are able to see from here, if the force is acting over the body, if I am considering any object and the length of the object is L, after the application of the tensile force, definitely the length will increase and diameter will decrease. So how I can write the strain? If the strain is unitary, what is the meaning of a strain? Longitudinal strain, change in the direction of the applied load to the original dimension of that direction. So what is the change? LF minus Li divided by original dimension is Li is equal to 1. Suppose the initial length is Li and after the application of the load, the final length become LF. That is the total length we are calling LF, and that is the initial length, original length of the body is Li. So what is the change? LF minus Li upon original dimension. So here LF is what? LF is 2 times of Li. What is the meaning of that? The meaning of unitary strain is after the application of the force, the length. What is the meaning of unitary strain? The meaning of unitary strain is the final length just double of initial length. If I am writing this, so I am able to write E is equal to sigma. With respect to, if the strain is unitary here, so I can write E is equal to normal stress. What is the meaning of that? The meaning of that, it means the normal stress is also defined as, or you can say the modulus of elasticity is also defined as the amount of normal stress required to cause the unitary strain. How I can define the modulus of elasticity? Another definition of modulus of elasticity is, modulus of elasticity is also defined as the amount of normal stress required for what purpose? To cause the unitary strain. And the meaning of unitary strain is what? Final length just double of initial length, right? So it is clear to everyone, I hope. Now I am considering, it means what happened? As the value of E is increases, as the value of E is increases, what is the meaning of that? The value of stress, normal stress will increase. What is the meaning of that? The value of normal stress is increasing. The value of normal stress increasing means resistance to linear elastic deformation increase. The meaning of stress is increasing in the body means the resistance offered by the body is increase. So, because the load is normal, because the stress is normal, so which kind of strain will produce? Normal strain. In normal, we are talking about the longitudinal strain. So, that's why I am writing resistance to the linear elastic deformation increases. When the resistance to linear elastic deformation increases, what is the meaning of that? The meaning is that change in length will decrease. What is the meaning the change in length is decrease? Longitudinal strain will decrease. Right? I hope it is clear to everyone. Again, I am repeating the same. Young modulus is also defined as the amount of normal stress required to cause the unitary strain. And what is the meaning of unitary strain? The final length just double of initial length. Means after the application of the force on the body, the final length is just double of initial length. Right? As long as the E is increases, the value of sigma n is increases. As the sigma n is increases, resistance to the linear elastic deformation will increase. Now we can consider an example. It is a very simple question to everyone. Suppose I have 4 different material that are made of, one is made of rubber, another is made of cast iron, mild steel and diamond. And the question is simple, which material is more elastic? Take a pause and try to understand this. I would try to give the answer of this question. Again, I am repeating the question. There are 4 different material. One is made of rubber, another is cast iron, mild steel and diamond. Which material is more elastic? So the example is simple. We having the 4 different material. One is made of rubber. I am representing rubber by R. Another is made of cast iron. Third is made of mild steel. And fourth one is made of diamond. I am representing diamond with D. And we are applying the normal load. And normal load is tensile load. Suppose here acting is PA. Here acting is PV. Here acting is PC. Here acting is PD. And after the application of the force, suppose we are interested to the unitary strain. If we are applying load for the unitary strain, what is the meaning of that unitary strain? After the application of the force, the length, final length just double of initial length. Okay. So after the application of the force, the initial length is just double because we are saying the unitary strain. The meaning of unitary strain is final length is just double of initial length. So now the question is again simple. Which material is more elastic? I hope the question is clear to everyone. I am interested to know which one is more elastic. Right? So simply we can say, as we have studied the modulus of elasticity, and modulus of elasticity is also defined as the amount of normal stress required to cause the unitary strain. Means the modulus of elasticity is nothing else that is equal to the stress for the unitary strain. And what is the meaning of stress? Internal resistance force developed in the body against the deformation due to the load. Means in which case more force is required to cause the unitary strain. So definitely anyone can see in diamond we required more force to cause the unitary strain. Means force required in case of diamond is greater than the force required in case of mild steel, and greater than the force required in case of cast iron is greater than the force required in the case of rubber to unitary strain. Because diamond is the very hardest, or you can the brittle material which offer the more resistance against the deformation. So the definitely modulus of elasticity of diamond is greater than the modulus of elasticity of mild steel, and this is cast iron and this is for rubber. So simply we can observe here which material is more elastic. Diamond is more elastic. Why the diamond is more elastic? Because it offers the maximum amount of resistance against the deformation. More force is required to cause the unitary strain. So that's why a material which having the more value of E is the more elastic. So as per the guidelines, you can say the value for E rubber has 10 gigapascal. These are the standard value. E for cast iron is 100 gigapascal. E for mild steel 200 gigapascal. Can anyone imagine what is the value of E for diamond? Surprisingly, the value of E for diamond is 1200 gigapascal. So we can also see the value of E means 1200 gigapascal force required to cause the unitary strain in case of diamond. That's why the diamond is more elastic. I hope this is clear to everyone why we use this modulus of elasticity and what is the significance of this modulus of elasticity and which stress and strain is used to develop the relations and for which stress and strain it is used to develop the relation. So next is modulus of rigidity. So second one is modulus of rigidity. Modulus of rigidity generally used to develop the relation between shear stress and shear strain. If we are interested to calculate shear strain theoretically, we can use the modulus of rigidity, right? So within proportional limit, again we can say within elastic limit or proportional limit, both are the same. Shear stress is directly proportional to the shear strain. As we remove the proportionality sign, so a constant come into the picture, that is called modulus of rigidity. Okay, so we can calculate shear strain theoretically here, that is tau by G. The value of tau is known to us. How we can calculate tau? If the force is tangential to the surface, so the load tangential force and which area we have to consider? Area which is parallel to the tangential load or surface area. Means this shear stress we are able to calculate that theoretically because we know the external force, the value of external force, and we also know the area of the body. G is fixed for any material. The value of G is fixed for any material, so we also know. So if tau is known to us, G is known to us, so we are able to calculate shear strain theoretically, right? So that is the significance of modulus of rigidity. Now, and this phi is nothing else, shear angle, and shear angle is nothing else, that is known as the shear strain, because shear strain is represented in the angular deformation. Because in case of shear, there is a possibility of shape change under the action of the tangential load. If the load is normal, there is a possibility of dimension change. If the load is tangential to the body, there is a possibility of shape change, right? So that's why it is always represented in angular deformation. So that's why we are representing gamma, and gamma is nothing else, that is the shear angle. So shear angle is also known as the shear strain. So again, if I am saying that for the unitary shear strain, what is the meaning of unitary shear strain? Phi is equal to 1, means the final angle just double of initial angle, or we can say G is equal to tau for the unitary angular, for the unitary shear strain. What is the meaning of unitary shear strain? After the application of the tangential length, the final angular deformation is just double of initial angular deformation. When this happen, what is the meaning of that? Means modulus of rigidity is equal to the shear stress. So the modulus of rigidity is also defined as the amount of shear stress required to cause the unitary shear strain. And the meaning of unitary shear strain is the final angle is just double of initial angle, right? So, the second definition of modulus of rigidity is, from here we can define modulus of rigidity can also be defined as the amount of shear stress required to cause the unitary strain, and the meaning of unitary strain is final twist is just double of initial angular deformation, right? Means as the value of G is increases, what is the meaning of that? The value of modulus of rigidity is increases, shear stress is increases. What is the meaning of that? The shear stress is increases, stress is increases in the body, any kind of stress. If the stress is increases, that meaning resistance in the body is increases. So, what is the meaning of that? Resistance to angular. In the previous modulus of elasticity, we have seen that is the linear elastic deformation. Now we have to consider angular elastic deformation, because due to the tangential load there is a possibility of angular deformation. So, resistance to angular elastic deformation increases. If the resistance to the angular elastic deformation increases, what is the meaning of that? Change in angle will decrease. Change in angle will decrease means shear strain will decreases. Correct? The same way we have defined the modulus of elasticity, same way we can define the modulus of rigidity. The only difference is in case of modulus of elasticity, we are developing relation between normal stress and normal strain. Here we are developing relation between shear stress and shear strain, right? In case of normal strain, there is a dimension change only. In case of shear, there is a shape change. That's why we have to consider the angular dimension here. Okay, I hope it is clear to everyone what is the significance of modulus of rigidity. Now come to the another elastic constant, that is modulus, bulk modulus. Third one is the bulk modulus. Bulk modulus is used to develop the relation between volumetric stress and volumetric strain, or to calculate volumetric strain theoretically. If we are interested to calculate volumetric strain theoretically, we can use the bulk modulus, and it is represented by K. So, first we have to understand what is the meaning of volumetric stress. The meaning of volumetric stress is that if we are applying the same stress in all the direction, just like this, if we are applying same stress, right? If we are considering any three-dimensional body, suppose we are considering any cubical body like this, correct? This is the, suppose this is x direction, these are the coordinate system y and z. If I am applying force in x direction, so the stress induced in x direction is sigma x. If I am applying force in y direction, Py, so we are able to calculate stress is sigma y, just divide by the area of that plane, and that is the stress induced in z direction. Now this figure is representing triaxial state of stress, because in all the direction the value of stress is different. Okay, so value of stress is different, that meaning this figure is representing basically triaxial state of stress. Triaxial state of stress, because stress is different in all the direction. If these stresses are same, means sigma x is equal to sigma y is equal to sigma z is equal to sigma, means in all the direction the value of stress is same. So in that case the stress induced is known as the volumetric stress. That's why the volumetric stress is also represented by P, pressure, hydrostatic pressure, because the intensity of the pressure is same in all the direction. So volumetric stress generally compare with P, pressure. Why we are comparing with pressure? Because the intensity of pressure in a fluid is same in all the direction. So that's why we also represent In that case, this figure will represent, if the stress is same in all the direction, volumetric state of stress, volumetric state of stress, or we can say hydrostatic, because we are volumetric stress is nothing else, it is just like a pressure, because the intensity of pressure is also same in all the direction. If stress is also same in the all direction, that is also known as the volumetric stress. So volumetric stress can be compared with the pressure. So we can also write here hydrostatic state of stress, hydrostatic state of stress. Means after the application of the stress, after the application of the force, whatever the change taken place in all the direction, that will be the same, because the stress acting in all the direction is same, right? So whatever after the application, if I am assuming this is sigma, this is sigma, this is sigma, means stress is same in all the direction. So the after, if I am considering a cube, so the after the application of the force, the value, the change, whatever the change taken place, that will be the same in all the directions. Suppose it is delta, suppose this is dimension is A, so after the application of the force, that will be the A delta, and A delta will be same in all the direction, because stress acting in all the direction is same, right? That is the meaning of triaxial state of stress, because in three direction the stress is acting. If sigma z is 0, what is the meaning of sigma z is equal to 0? The meaning of that, in that case, the stress induced is known only, there are two stresses, one is sigma x, another is sigma y, that is 2D. This is for triaxial is for 3-dimensional, and biaxial, this is known as, this figure is representing biaxial state of stress, biaxial state of stress. If we are considering sigma y is also 0, if sigma y is also 0, that case is known, means this is only the sigma x is acting over there. That figure will represent, what we can say it, uniaxial, uniaxial state of stress. I hope this concept is clear to everyone. Why we are calling triaxial, why we are calling biaxial, uniaxial. Triaxial means if the stress is different in all three directions, that is called triaxial state of stress. Biaxial means if we are not considering any stress in the z direction, means sigma z is equal to 0, only in two direction if the stress is acting, we are saying biaxial stress. If we are considering only one dimension stress, that is known as the uniaxial. Triaxial, biaxial, uniaxial, and volumetric. Volumetric means if the stress acting in all three directions is the same, just like the hydrostatic pressure, correct? So I hope volumetric stress is clear to everyone. So generally this is bulk modulus is used to develop the relation between volumetric stress and volumetric strain, or you can say to calculate volumetric strain theoretically. So we can say within elastic limit, volumetric stress is directly proportional to the volumetric strain. As we remove the proportionality sign, a constant come into the picture, that is known as K. So K is known to us, we are able to calculate the volumetric strain sigma V by K. So this way we are able to calculate volumetric strain theoretically, right? Now, if the volumetric strain is unitary, what is the meaning of that? The volumetric strain is unitary. The final volume just double of initial volume, as we have already mentioned. Final volume is just double of initial volume, right? And what is the meaning if the volumetric stress is 1? We can say K is equal to sigma V. K is equal to sigma V, right? So the bulk modulus can also be defined as, the second definition of bulk modulus. Bulk modulus can also be defined as the amount of volumetric stress or hydrostatic pressure is required to cause the unitary volumetric strain. And the meaning of unitary volumetric strain is just final volume is just double of initial volume, right? I hope it is clear to everyone. So that's why we are representing by pressure. So this sigma V is equal to, you can write epsilon V is equal to sigma V by K. In place of sigma V, we can write just we can put here pressure, because we are representing sigma V is nothing else, that is the P. So that divided by K, so K is equal to nothing else P over epsilon V, and what we can write the epsilon V, change in volume to the original volume, right? And volume and pressure always in opposite side, so that's why we always write P Vp over delta V. This way we are able to define the formula for the bulk modulus. And what is the significance of this bulk modulus? So a general example we can consider, suppose we all use the LPG cylinder in the house, and we have seen LPG cylinder means that the gas is inside the cylinder. When the gas is inside the cylinder, always exert pressure on the wall of the cylinder, and the cylinder is always kept at a particular pressure, right? After some times what happen, because the material is always under threat means under load, because the internal pressure is always there. After some times what will happen, the expansion of the cylinder will taken place. When the expansion will taken place, so definitely we have put extra gas to maintain the same pressure, because LPG cylinder always filled or maintained at a particular pressure. Because the volume is increases, so definitely the pressure will decrease. So how much extra volume we have to put inside the cylinder to maintain the constant pressure? So from here we can calculate delta V. So delta V is nothing else, that is Vp by K. K for any fluid is fixed value, it is the experimental evidence. Volume we already know. At which pressure we have to maintain, we have to fill the gas, we know. So we are able to calculate how much extra volume we have to put inside the cylinder to maintain the same pressure. So generally we can easily observe the cylinder which is older one definitely have the higher weight, because there is a expansion of the walls, and when the expansion taken place, so we have to put the extra volume to maintain the same pressure. So definitely we can observe a older cylinder always have a more weight than the newer cylinder, right? So I hope this concept is clear to everyone. And the last one is the Poisson ratio. So Poisson ratio basically used to develop the relation between lateral strain and longitudinal strain. Already we have developed the relation for the longitudinal strain, means longitudinal strain theoretically we have already calculated. If we are interested to calculate lateral strain theoretically, so by using the Poisson ratio we are able to calculate lateral strain theoretically, right? So what is the meaning of that? Means within elastic limit we can say lateral strain is directly proportional to longitudinal strain. Means that is epsilon y or epsilon z is directly proportional to the, you can say, epsilon x. If I am assuming the strain in x direction is the longitudinal and other direction are the lateral. If I remove the proportionality constant, a constant come into the picture, that is known as the mu. So I can write mu is equal to minus lateral strain, because these are also opposite in direction. That's why negative sign come into the picture. Lateral strain upon longitudinal strain. So mu for any material is fixed. Longitudinal strain already we have calculated with the help of modulus of elasticity. If we are interested to calculate the lateral strain theoretically, we are able to calculate from here, right? Means generally the value of mu for the cork, there is a cork material, the value of mu for the cork material is 0. Mu for concrete, the value for the concrete is nearly about 0.1. Mu for any metal, any kind of metal, values lies between 1/4 to 1/3. Mu for rubber, the maximum value of mu is for rubber, that is 0.5, right? I hope it is clear to everyone. The meaning of cork material is mu is 0. What is the meaning mu is 0? Anyone can guess? What is the meaning of that? The value of Poisson ratio is 0. It is very simple meaning. Mu is 0, just like anyone has seen the cork material. The cork material means the cork has the property, just like you can see the shuttle, you have seen the badminton shuttle. In badminton shuttle, the bottom part is the cork, just like a cork material. The meaning of cork material is, and the mu is 0, mu means lateral strain over longitudinal strain. What is the meaning of 0? Means the lateral strain is 0. Lateral strain 0, what is the meaning of that? Mu is 0. What is the meaning of that? Means in which direction we are applying the force, the change is taken place only in that direction. So in case of badminton shuttle, we can easily observe in which direction we are applying the force. You can observe it. If you are pushing that cork part of the shuttle, you can easily observe in which direction you are applying the force. The change is taken place only in that direction. There is no change in the lateral dimension. Lateral means perpendicular to that, there is no change. So that's why the mu is 0 for that. And that mu is maximum for rubber. Easily we can observe what is the meaning of rubber. The mu is half. Means whatever the change taken place in lateral dimension, just double of change taken place in the direction of the applied load. Right? So that's why this mu is also very important. It has a significance to calculate the lateral strain theoretically. I hope this elastic constant is clear to everyone. Thank you. In next class, we will develop the relation between these elastic constant. Okay.